You see the screen?
So,
How was the test?
I haven't joined it yet, sir.
But today is supposed to first test, no?
Yes, sir.
You're not joined.
Mm,
Okay. What about that physics wala? It's only 1,800.
but I don't want the class, no, sir. I just want test series.
No, but it's everything is included in that. And
March they are starting.
Yeah.
I don't want the class, sir.
no, if you don't know the class, don't watch it. It's just recorded videos only. But you can take the other things. So test and all will be there. The important thing is it's only 1,800. So it's almost free.
And NEET test series about 300 physics scholars they are providing, sir. I want an offline test series. I'm getting free tests from Telegram itself. From Akash, Alan, everything is available, sir.
Okay. Right. Okay, so we'll continue with this one. Class 11. With this question. Try this one. This I'm making some mistake, I think. You getting the answer?
No.
Yes, remember that. Okay. I don't think it's difficult. Okay, you can write both velocity and acceleration in terms of x. So velocity is so it's omega into so 1 square root of 1 minus x square. Is that right? X square is a square, sine square is a square, well, so a square minus x square, right? Is that right? Velocity is x omega into square root of a square minus x square. So basically x will change with time, so velocity will change with time. So instead of writing the variation of x velocity as this one in terms of time, you can write in terms of x, where x is changing with time. Similarly, acceleration also, this you'll get, right? A cos omega t is 1 minus a square, sorry, a square minus a square sine square omega t square root. Right? So a square minus this one is this one, and acceleration is minus omega square x. Right? So this, so here that you can use here. Okay, so from there you will get omega. Once you know omega, you will find t. Got it?
Right, sir.
So this is the one. Velocity is this one, and acceleration is this one. Omega square x. When x is positive, acceleration is negative because okay, it's magnitude. That's why the minus sign is not there. Okay, so then you have to do this one, and he has given at x equal to 2. So putting that, you get omega. Once you know omega, you'll find the ampere. So which option is that?
Third option.
Yeah, option C. Right. I try to do it this way. So when I put this one, so what a mistake I'm making here. Omega A will get cancelled. Oh, omega is remaining here. A will go away. So from this, I'll get omega as okay, omega is there. Omega will remain, and then here omega is there. Okay, this is not the way to do it. So say there is another omega. Right. Try this one when two displacements y1 and y2 are superimposed. Motion is a trivial question, theoretical question. So what will happen when you combine sine and cos? It's already covered in theory, no?
Simple harmonic combination with that amplitude is cos
It's A sine omega t plus b cos omega t. So the standard technique is divide by square root of a square plus b square, and then it will get multiplied by square root. And this thing I can write is as cos phi. Okay, so this will become sine phi. So the full combination is sine of omega t plus phi. So this is an SHM, and the amplitude of the system is square root of e square plus b square. Is it clear?
Yes, sir.
It is already done in theory. 9C. Okay. So similarly, if I combine sine and another sine, what will happen? Here I'm combining sine and cos. Okay. So similarly, if I say A sine omega t plus B sine omega t, what will happen? This is trivial, no? This will be A plus B sine.
A plus B magnitude.
Yeah. So right. Okay. Suppose if there is a phase difference, there will be there should not be any phase difference. Fine. This is trivial. Even cos plus cos is a trivial thing. So even sine and cos, you have to do this one. Okay, a particle is executing SHM along a straight line. Its velocities at distances x1 and x2 from the mean position are v1 and v2 respectively. So its time period is. Try this one. V2 will be x2. Okay, divide these two. I'll get, I will not get. Okay, instead of that, I can write. So divide these two. Getting the answer?
No.
So this is expression for velocity, right? Omega square into square root of omega into square root of e square minus x square. So this is clear. So basically, I have to find omega. Right. So we have to eliminate a. Yeah, this is a trivial thing. So when you subtract these two, I'll get omega square. Right. After that, I'll get ampere. Is it clear?
Okay.
So you have to remember this formula for velocity: omega into square root of e square minus x square. And what is the formula for acceleration in terms of x? Minus omega square x.
And that's space difference of 5. Okay.
So basically, velocity and acceleration are functions of time. Okay. So, but instead of function of time, I can also write in terms of function of x. Okay. So here the variation of velocity with respect to time comes because of the velocity variation of x with respect to time. Got it?
Sorry, what's that?
No, in SHM, both x is function of time. Okay. And velocity is also function of time. Acceleration is also function of time. Yes or no? All sine, cos, sine variations. Right?
Yes, sir.
Okay. But when I'm writing in terms of x, it becomes omega into square root of a square plus square. But here the time dependency comes because x is a function of time.
Yes, sir.
Acceleration time dependence comes because x is a function of time. Okay. So this is also a basic formula that you have to remember or you have to quickly derive. Once you have this one, velocity is a square minus square and acceleration is minus omega square x. Right. So this one, a particle is executed in SHM. Maximum acceleration is alpha. So in SHM, acceleration is all variable. So when is the acceleration maximum? At the mean position or the extreme position?
Negative amplitude, sir.
It will be at the extreme position, right? Acceleration maximum. Because of the extreme position, suppose if it's a spring, the string will be stretched maximum. So the force with which it's pulling back will be maximum here. At the mean position, the spring extension is 0. So the force with which it's pulling is 0. So here the acceleration is 0, but the velocity is maximum. Okay, here the velocity is minimum. Velocity is 0, but acceleration is maximum. Right? And maximum acceleration is alpha and maximum velocity is beta. So velocity at this mean point is how much?
Maximum.
No,
Omega.
no, here in this question it's beta. Okay, in this question
Okay,
it's
omega. Beta.
Alpha and beta have some constants. Okay, so here the acceleration is alpha. So from that we can, again you can use the same formula. Velocity is omega into square root of a square plus x square. Acceleration is minus omega square x. So use that velocity at the mean point and acceleration at the extreme point. So put those values and you'll get omega. What is the answer? The velocity maximum is beta, right? So it is x equals 0. Acceleration maximum is it?
2 pi beta by alpha. Option D, sir. Fourth option.
Yeah. So this is the formula you have to use. And you have to use the correct position. Velocity means velocity maximum is output x equal to 0. Right? For acceleration output x equal to 0. Got it? This one 12. Okay, this was a trivial question. Theoretical question. But you have to as you get the exact meaning of this thing. So t equal to 0, the particle is where? The body is where?
Mean position.
If you put t equal to 0, what will you get here? X as?
0.
No. T equal to 0.
What? Maximum.
So initially it's at the extreme position. So at extreme position, what is the acceleration?
Negative.
Maximum. Magnitude is maximum, but positive or negative we can disagree.
Negative. C is our option. C.
Another thing is you can blindly differentiate this thing twice. So first you will differentiate it a omega minus sine omega t. Okay, and second we differentiate a omega square sine omega t. Sorry, cos omega t. So basically the acceleration is minus omega square x, right? So it is minus of x and some scaling factor. So cos, so it will be minus cos. So this is minus cos. Got it? Acceleration is minus omega square x. So whatever is the x variation, multiply with minus 1. So x variation is cos. Okay. So if you multiply by minus 1, it become like this. So this is minus cos.
Yes, sir.
Okay. And some factor is there, that's omega square. That we also can do. Done?
Yes, sir.
This one 13 out of following functions. This is a theoretical question. This is NCERT question. Sine minus cos. Sine, Sine cube, right?
It's A also represents 1, 3.
Okay.
1 and 3 are option C.
So option 1 is SHM or not?
SHM.
Okay. What about option 3?
SHM.
Okay. Option 4?
No.
It's not SHM because the time will keep on increasing. SHM means it has to come back. It has to come back. And this one is sine cube. Okay. If it is sine square means it will be SHM because sine square can be written as 1 plus cos 2 omega t, right? Cos 2 omega t by 2. So it is SHM plus a constant. So it is still an SHM. But still it is sine
So the sine square SHM.
Yeah, I'll show. Sine square say omega t. This you can write as 1 minus cos 2 omega t by 2, right? Is this formula correct?
I don't remember.
Cos 2a formula is what?
Cos A, cos B minus sin A, sin B.
Yeah, but cos 2a is cos square a minus sin square a. Right. So this can be written as 2 cos square a minus 1. So, okay. I think, yeah, so this should be right. So similarly, this can also be written as 1 minus 2 sin square. This will get this correct. So cos 2 omega t. X-axis and y-axis, if we just shift it up, this whole thing by sine cube. Here it is sine cube, so it's not in the system. Got it?
This one sin square also.
No, sine. Okay. Cos a plus b formula is cos a cos minus b, right?
Cos square A minus sin square A. After that, what have you written? 2 cos square minus 1.
Yeah, sine square is 1 minus cos square, no?
Okay.
Or you can write in terms of sine. Cos square I can write 1 minus sin. So from this, I'll get sine square as 1 minus cos 2a by 2. This is half angle formula. You are writing
How
only.
did you write it? Okay, fine.
If it is sine means it will be minus, if it is cos means it will be plus. Okay, so this part is SHM. Okay, so this will be like this, and I'm shifting it up by half. So it will be an oscillation here. So this also in SHM. But sine cube omega t I cannot write like this. Okay, this 14th one.
Simple
Yeah, just now I explained this.
Pi by omega. Option A, sir.
Yeah, but the frequency will be doubled. It will be 2 omega. Okay, this frequency means he's writing the time frequency. So omega equal to 2 pi f, right?
Yes, sir.
Omega is 2 pi f. So here the omega is 2 omega. So from this I'll get the frequency as omega by pi. Putting this C. No, it is simple. Okay, maybe is going to different. No. This cos omega t can write in terms of sin square omega t. So you'll get omega square x plus something. So the question is, if you're considering this as SHM, an oscillation about this one, will you consider the oscillation which is shifted up as also as an SHM? According to me, it is true. So this is the answer according to me. Anyway, it's an old question, 2010. You got the idea, no? Okay. So, but if he defines SHM as the oscillation about x equal to 0 or the mean displacement should be 0, then you can say this is not an SHM. But SHM is oscillation even about a different mean level. Done?
Yes, sir. But if this same question is asked in NEET, then what should I choose?
This is CBSE 2010. I would say it's an SHM only. So someone will, after the exam, someone will raise a complaint, no? So they will give correct marks for both. They might. But if this is, but this is the correct answer.
Mark, even if it is wrong, and what is written in
Forget this is 2010, so I do not know what is the situation now. So according to me, this is a system only. So leave it. I would say you take it as this one, E only.
Okay.
Which of the following equation motion represents simple harmonic motion? So the same question. So option C, D, B, C, D are out. So the option A remains. B.
Option acceleration minus k times x only, no, sir.
Oh, okay.
K will be omega square.
Yeah. So
option
B is valid.
Huh?
Option C is out. Option D is out.
So why option C is not valid?
No, B is okay.
K our positive then
It depends only linearly on x. E is also out. Depends quadratic as x. And it should be minus x. So only B is remaining. Okay. He has going to. So correct option is option B. Okay.
And if K was negative consonant, then option D is the right one, master.
Yeah. He has given us positive. Okay, this is also a trivial question. So omega is given. Amplitude is same. Yeah, so acceleration is minus omega square x, right? So V1 by V2 is omega 1 by omega 2 whole square. 1 by 10 is 1 by 100. Done? Is it done?
Yes, sir.
Okay, yes, we know 2008. Let me do this something else. This is 2021. What's the answer?
So I have to convert the centimeter into 10 power minus meter.
Yeah, that's why it became 1 by 100, or it should become 100. Yeah, it should become 100. So omega is 10. Yeah, that's a mistake. So this will become 100. So omega is 10. 2 pi is 6.28, so it's 0.68. 0.68 is option B. Done.
TV para 2 pi by 10, okay, 0.9.
Yeah, 2 pi by 10.
Yes, sir.
Is this formula correct?
Yes, sir.
Simple pendulum. Right. And the time taken to fall from height, does it depend on G?
Yes, sir.
From a height.
And G depends on mass of the planet.
Dropping
G
from a
and
equal to half GT square, right? So T is 2h by G root. This is the time taken. So in the second case, the time T2 will be 2h by G2. Okay. And okay, so T, this one is 2T. Okay, so we have to find what is T2. So T2 is so the second thing, mass of another planet is how much? Mass is half, radius is same. So G is Gm by r square, right? The definition of G is it's a force acting on a unit mass. So G into m into 1 divided by r square. R is the radius. Radius is same. So mass has dropped down. So G2 is half G, the original G. Okay, so GT if you put as half G, so root 2 will come up. So it's root 2 root 2. This is the formula for G, right?
Yes, sir.
Okay, so mass is half. So G2 will go down because radius is same. So G2 is going down by half. It's not root. Because 2 into 2. No. It is root 2 only. So T2 is G2 is G by 2. So root times. Oh, yes, he is writing in terms of T prime, not in terms of T. And T prime is 2 pi
2 pi root of
L by G prime. So G prime is G by 2. So here there will be another root factor. Root 2 times. Okay, so root 2 times T is 2T. Okay. Yeah, T is 2T. And this, in terms of T prime, it is T prime by root 2. My God. You getting the answer? See, this is correct now.
Yes, sir.
This is correct. And then T is square root of 2G by H1. And this T, this is going to be 2T. This is also correct. Okay. And T2 is square root of G. And then G2 is half of, so this is root 2 times T. And then T is 2T. So, and then T and T prime is square root of G prime. And G prime is by 2, so it's root 2 times T. This is also correct. So capital T I have to put as T prime by root 2. So capital T is T prime by root 2. So this will become 2 root 2 into capital T is T prime by root 2. So root 2 and root 2 will cancel. So 2T prime will remain. Is it clear?
Yes, sir.
Okay, you have to do it carefully. The basic relations are this one: time period of the pendulum, and then G is Gm by R square. Okay, and then time to fall is square root of 2H by G. Okay, since G is changing, things will change, and he's also writing the thing in terms of T prime, which is the oscillation of the pendulum in the second case. Got it?
Yes, sir.
It's a lengthy question. The pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a oscillator. Okay, that's going to go. Yes, it's a trivial question only. Acceleration is minus omega square x. So acceleration is how much? 20 minus omega square, and x is actually it's magnitude of acceleration. So just forget the sign. This is at x equal to 5. Acceleration is a variable acceleration. So for this particular value of x, the corresponding acceleration is 20. So using that particular point, the omega square as 4, so omega is 2, and then t is 2 pi by omega is 5. What this one?
Yes, sir. So if the string is cut from the, I think the string function will remain same actually for the period. Option B. I think that
No, C.
the spring constant change for different length of the spoon spring, sir.
Okay, so if the spring, suppose if the spring has got n turns, okay, and the spring constant is k, and suppose if we take just one turn of this spring, okay, so what is the spring constant of this v1?
K by N.
It will be more, n times k.
Hmm.
The thing is, this spring constant is basically the force required to compress it, no? Equal to kx, okay, k is force required to compress it by 1 unit distance. Okay, so if there are n turns means each turn has to compress by that fraction. Okay, suppose I want to compress by 1 centimeter, so each turn has to compress by 1 by n centimeters. Okay, so it's easier to compress a spring which has got more turns. So if we just take one turn of this one, the spring constant would have gone up by n times k. Is this clear?
Okay.
Suppose if we want to compress this 5 turns spring by say 1 centimeter, so each turn has to compress by 1 by 5 centimeter, right? Because the total compression is 1 centimeter. So if you have to compress this spring as a whole by 1 centimeter, so each one has to compress by 1 by n, right? So it's easier to compress a spring which has got more turns. But suppose if we take single turn, the material is same. Okay, but if you have to compress this single turn spring by 1 centimeter, this whole thing has to get compressed by 1. So it's 5 times, 10 times more difficult.
Okay.
So the spring constant of single turn is n times k. There is n is number of turns of the spring. So the original spring has got n turns. In the second case, it will have n by 6, 1, 2, right? So total parts is 6. So this is 1/6 of that. Okay, so it will be 6 times k. Okay, this one will be 3 times k, and this will be 2 times k. That's what I written here. Spring constant will become 3k. Okay. When I'm connected in parallel, the spring constant will be easier to compress the spring. So k will go down, so the reciprocals will add, right, in parallel. or it's opposite?
In parallel connection will get added, no, sir. It's like resistance and
So
series.
K prime is then equal to 6 plus 3, 9, 9 plus 2, 11. 11K.
K double dash is 11K.
K double dash is 11K. And series, I'm just say if I take and cut it into two parts. Okay, like compress these two ends is the same as compressing these two without cutting. Got it? If you take a full spring and try to compress it, okay, so each turn will compress by an equal amount. Okay, but if I split it into two parts and then join them and then compress it, it's exactly same situation. The spring constant, when it is cut and connected in series, it's the same as the original spring constant. Okay, the answer is 1:1. K is more means it's difficult to compress a spring. The spring is tight. Because if K is force per unit compression or extension. So K more means the spring is stiff. So springs connected in parallel will be stiff because yes, it will be stiff compared to series connected spring. So this thing you understood? When I have the original spring and I just cut them and then join them, it's exactly same. Because the force I will be applying at the end. Here also force I'm applying at the end. So both are exactly same situation.
The higher the value of K, the more stiff the spring will be, sir.
No, see, suppose I have a resistance 3 ohms. Okay, if I split into two parts and connect them in series, what is the total resistance? Same, right?
Same only, sir.
So similarly, the spring.
Parallel means that we get a.
Yeah, parallels will get combined. See, this is how you have to understand. So if you take a full spring and try to compress it, okay, so each one will compress by 1 by total number of turns, right? So it's the same thing if you apply the same force. Here also is exactly the same situation. I split it into two parts and connected by a rod. So it's the same effect.
Okay.
If this thing had 5 turns, and here I made it say 2 turns and 3 turns, and after applying a force, so each 5 turn, each one turn will compress by 1/5 of the total compression. Here also each turn will compress by the 1/5 of the total compression. These two are exactly equal springs. So when connected in series, the spring constant is same.
Yes, sir.
The answer is option C. Okay, this is a simple question. You just have to use the formula straight away. What is the formula for time period? In terms of K and M. You have to give the time period in terms of K and M. You remember the formula?
What, sir?
What is the formula for T in terms of K and M? This is a spring mass system, right? This is M and this
2
is
by root of M by K.
use that.
But here we don't know about the K constant, no, sir.
The same spring, no, in the two cases. So K is same for both. So we cancel. One is so if we divide these two,
960 D. Option D.
yeah, it's D. Is a trivial question, formula based. Got the answer?
Fourth option D. Root 3 times 5 A by 2. 5 A by 2.
So this is the formula you use, right?
Yes, sir.
So omega you can write as 2 pi by T. So I understood the question. So it's a standard question, but I don't think it's. Is this free body diagram complete? No, it is complete. Okay, so let me assume acceleration is upwards. So normal reaction minus mg is mass and acceleration. So when it is just about to leave contact, what will happen in normal reaction?
Sorry, what?
When the mass is about to get detached, what will happen in the normal reaction?
I don't know.
0, right?
Normal reaction is actually exerted by the spring motion. It's just spring force.
There is a contact here, no? Okay, there is one more
Between
force.
the and the mass.
There is one more force, no? Okay, so where will it lose contact? See, right now the thing is, so once it oscillates, it will oscillate like this, no? It will go down, and then it will turn back. See, this is the mean position, and then it will go up. So which position do you think they lose contact? It's easier to lose contact, the downward position or the middle or the upward position. It lose contact here, or here, or here, or here, or here. Where it's easier to lose contact?
I have no idea about it.
See, in this at the bottommost position, mg is downwards. Sorry, mg is downwards, and this spring force is upwards.
Spring force is upward.
Spring force. Okay, so it is possible for normal reaction to become 0 in the bottommost position. In the top position, spring force is upwards. Spring forces the spring is going to get stretched, no? So spring will try to pull it down. No. Yeah, actually this direction of Ax is going to change. So if you take the bottommost position, here the spring is compressed. So the spring is compressed, the direction of Kx is this one. This diagram corresponds to bottommost position. Okay, similarly, if I draw the diagram for the top position, so the exact everything is same. In the top position, the spring is stretched, so it will try to pull it down. So Kx will be downwards. Moment action is always upwards. Weight is always downwards. Okay, so here normal action is this plus this. So, but here normal action has a tendency to become 0 if Kx is mg, right? Getting confused. The option is correct. The bottommost position is compressed, so spring will try to push it up. So Kx is upwards. Okay, in the normal direction.
Here, this mean position means equilibrium position.
Just we'll come back to mean position later. At the topmost position, normal direction is upwards, weight is downwards. I try to pull it back. Okay, when it's trying to. Oh, the spring is trying to pull back the platform. Okay, Kx is acting on the Okay, I'll come back to this later. Okay, here once a small mistake is there. Kx is not acting on this mass. Kx is actually acting on this platform, and the platform and the contact between platform and the mass is only the normal reaction. So spring force is going to act only on this platform, so it won't act directly on the mass. Okay, if this is free body only of the mass, Kx won't be there. Okay, there is no contact between the mass and the spring. There is contact between mass and the platform, this platform. Okay, and the spring is connected to the bottom of the platform, so there is no connection between mass and the spring directly. Okay, so the connection between the platform and the mass is the normal reaction. Okay, and this acceleration will become function of x, function of, this will depend on k. So that will give a relation between n and k. So I'll get back to this later.
Okay.
Okay, this is also a standard question. This one.
I don't want to know the question.
What is upward force?
Thrust.
Buoyancy force, right? It is weight of the liquid displaced. So let this height be x, because it's going to change. The height, that's the volume of the liquid. That is this volume. That is area of cross section into x. That is the volume into density of the liquid. This is the buoyancy force. Okay.
And G.
Into G. Weight of the liquid. So the net force acting on this one is
FG minus
G minus V. So this force is proportional to, so this is a constant. So if this force is think in terms of kx, so hence you'll get k as E O G. This is k, right? And period is pi into square 1 by k.
So how did you get that place, or I can't understand. So for clear reason.
SHM force is minus kx, no? What is the condition? So forget this constant. So as a function of x, this is the term. So there is a constant that is multiplying x. And E and G are all constants. This is key. Constant. So dependent on okay, it depends on M also. So this is true, B is true. It's actually proportional square root of M. So B is true. This dependent on density. Density has 1 by root G. That is not given. So only B is true. B. This is a standard way of checking whether a motion is a system or not. You have to get the net force, and the net force should be proportional to x, and the direction of the force should be negative.
So that volume, we have to take the volume of the liquid only, no, sir.
Buoyancy force is the weight of the volume displaced, no? Liquid displaced. The volume of weight of the liquid displaced is this corresponding to this volume, which is submerged.
Oh,
Okay. When the submerged volume is dependent on this height, and this is a variable height because it will oscillate. Now let's just call this height as x. Okay. So you get the force as x, and if x is changed by forcing it, by pushing it down, there is a force which is proportional to minus x. And that is the condition for SHM. If a force is of this type, then it's an SHM. So the buoyancy force is the volume of the weight of the volume displaced. So this one, the buoyancy force. Okay, he has not considered mg. So you have to see the net force acting on the body, which is mg minus s1. So it's a constant. You can never forget it. So the force, which is it's a variable force, which is of the type minus kx. So from that we get k as that one. Got it? Okay, this is also a standard question. This is even a simple pendulum. Why do you think it's a it's a simple harmonic motion for small oscillations, right? How do you prove that? Again, the restoring torque is proportional to the displacement theta. That's an angular SHM. Here it's a linear SHM. So there we prove that the restoring torque is proportional to theta, some negative constant with theta, so it's an SHM for small oscillations. Okay, got it?
Yes, sir.
And what about the final NEET exam? Is it online or offline?
Offline, sir.
NEET exam is offline, is it? It's not online.
No, always.
Okay. So which test series are you going to join then?
I've asked the ACCA, sir. They're not providing offline.
Which one?
One is in Kerala NEET Academy, but my syllabus is not complete.
Okay. What about the test in that Physics Galaxy?
Physics Galaxy mark and part test they are providing. The separate test for me they are providing.
Okay, whatever the online test also, the thing you can do it as offline, no? What is the difference? See, the online test practicing as offline is difficult, but offline test, if you practice as online, then it's not difficult, no? Instead of having the paper on your hand, you just see the question on the screen. But everything else you'll be doing the same thing as offline only. So,
sorry, I don't get it.
See, if the final exam is online exam, okay.
No, it's offline, sir.
No, if it is offline, the mock test you can give online also. There is no difference, no. Online test can be given as offline.
No, that shading and all, it will require more time, no, sir.
No. What?
In offline. In online, you don't have to share, no, the bubble sharing.
No, you just take a printout of the question paper.
Yes, sir, that I have to do it.
Okay. So that's what you have to do. You have to take some offline mock tests, even if it is available online. Take the printout of it and then do it as offline. Okay. So for that you can use Physics Galaxy itself.
Yes,
Okay.
sir.
Physics Galaxy is free, no?
Yes, sir, very, very cheap.
Yeah. So try those tests as your mock test. That will do.
Yes, sir.
Physics Galaxy is a good resource.
Yes, sir.
Okay, we'll stop now.
Okay, sir. Sir, you're talking about physics wala, no, sir, it's not physics galaxy.
No. Physics Wala, you can join the course for 1,800. Okay.
They are providing test series also, sir, separately.
Which one? Physics Wala. Yeah. If you want this 1,200, 1,800, this thing, everything is there. Recorded videos for the theory part. Theory part means it will be compressed. It won't be like a normal this thing. It will be fast paced. And then mock test, part test will be there. And then mock test will be there.
Yes, sir.
You can go to their website and check.
Okay.
Or in the Physics Galaxy also you can get all the question papers. That also will be good. Actually, that will be better because if he's giving everything for free.
Yes. But they are not providing test series, no, sir.
Which one? Physics Galaxy.
Physics Galaxy has not started providing the test
Physics
series.
Galaxy I do not know, but Physics Wala has got everything. Test series, everything.
Yes, sir. Yes, sir.
So for everything costs 1,800 only.
Yes, sir, my friend was giving the Yaki in 2.0.
It is giving what?
Yaki in 2.4.
Physics Wala.
Yes, sir.
Yeah, so from her you can take the question paper.
Okay.
Okay, stop now.
Sorry, sir.